Hello, my name is Tony Lyle, an application engineer with Prolim, and today I'm going to show some best practices for setting up your manufacturing environment inside NX using the master model. We're also going to look at how to set up our blank geometry using modeled geometry, as well as how we can make that blank associative to your master model. So let's take a look. Again, we're going to use the master model concept, so I'm going to create a new file referencing this existing part. So in my manufacturing environment, the first thing I want to do is add some components. I want to add a vise into this manufacturing assembly. So I'll find a vise I have here. We'll move this in a location. And at this point, I want to go ahead and constrain my part to my vise using my assembly constraints. So I'll begin with a fixed constraint. And in this case, I'm going to use the bounding block, which is a very common practice, but it does have some limits to it. It can be a little bit limiting to your environment, and I'll show you some of those limiting factors here. But first, let's go ahead and do our assembly constraints, and this is going to show you the first limitation to it, where as we start doing we'll have to do distance constraints to constrain this part properly. So I'll have to plan for how much stock is on this part, perhaps 100 thousandths, and distance from the bottom to the top of the vise, we can move that one maybe 50 thousandths above the part. And we'll also look at another distance constraint, and this may show some of the real limitations. I want to go from the face of the jaw to this surface, and you see I'm getting an over constraint. Perhaps this isn't perfectly perpendicular with my vise jaw, so it's not able to do that one. So we'll try a different one, doing again the distance constraint just of this. We probably just need maybe this line right here to the vise, and there that one will work. So we can apply that one now. So we get a few different limitations that you really have to play around with some things when you have obscure parts such as this. Same thing over here. I'll have to find I'll probably be able to get maybe that. Nope, that one's not going to work. So I'll try a different one. From the vise face to maybe that line. And then I'll just move it in right about there. So now at this point, I would have to also set my MCS mill, and I'd like to just set it on the corner of my raw stock or my blank, which I would have to do a lot of measuring to do that. So again, you have a little bit of limitation to that, where creating an actual body for your blank will be more beneficial in a scenario like this. So once you do get everything constrained, the first thing we always want to do after the components and constraints is a wave geometry linker. We always want to do a wave geometry linker on the master model. So why do we do this? Well, we never want to make changes to the master model. This is the final released version of the model of the final product, either from your design or engineering team, or maybe even from your customer. But we still want to have the ability to make changes, any sort of manufacturing changes to the model for manufacturing purposes, such as a construction hole. Maybe you need to alter a corner radius slightly to adapt to your corner radius of your cutting tool, or maybe fit a tolerance a little better and move a face a couple thousandths here and there. This way the manufacturing changes made will not flow upstream to the master model, but any changes made to the master model, either by the design team or customer, will flow downstream to your linked body here in the manufacturing environment. So this is why we wave link, and we'll use this step in every scenario today. So once you do the wave link, we have a linked body here, but we also have the component showing. We don't need the component any longer, so we can just hide that one away. And this is what we'll actually use, the wave geometry linked body here as our workpiece, as our part in our workpiece. And then the blank, once again, will show the bounding block, and you would have to make these alterations. Maybe there's an 1/8 inch. Let's put an 1/8 inch around X, Y. This one we may just have to slightly move until it looks good, because unless you do a lot of different measuring techniques to do that. This side was only 100 thousandths, I believe. Z minus, we can move our part down 200 thou or so, and the top maybe just 50 thousandths. So that would be one case in which you could create that blank inside your vise. But again, I think it's a little bit limiting, and I want to show another scenario of how we can do all of that. So let's go back to our multi-tool master model. I'm going to create a new file once again, and we'll just have this as a setup 2. And just as before, we're going to go ahead and add that vise. We'll add our vise into the assembly. And at this point, I want to actually go ahead and create geometry for my blank, and I'm going to actually use that geometry with which to constrain to the vise. So I'm going to create a bounding body around this part, and I can set my size offset in here as an 1/8 inch single offset around all 6 sides, and then I can alter the top and bottom individually. So now I have a body created, built quickly around that master model, and I can use this and create a component out of this. Now I'll create a new component. I'll just name it blank 2. And I'm going to select that bounding body that I just created here, and we'll see the bounding body be removed from the part navigator, and it actually is created as a component here in the assembly navigator. So it's its own component and its own part file now. Now we can use this to constrain to the vise itself. Since we can't constrain bodies to components and vice versa, we have to have components. Those are the only things that we can really constrain together, are components. So we'll go through those same steps as the first scenario. We'll fix this first, and this is a really cool one. This is a bond command. I'm going to bond. I'm basically just gluing these together and creating that constraint, and they're going to move together now wherever they're bonded together. So now I can just do simple touch aligns. I could touch that back surface to the vise jaw. We'll do a distance constraint to here. That was 200 thousandths on the other one. So we can really quickly set this part up. At this point, we can really quickly set this part up with using fast assembly constraints, not having to measure things and worry too much about all the other things going on with potentially non-planar surfaces and so we don't have to worry about surfaces being planar to one another to be able to do those touch or align constraints in the assembly constraints here. So now, again, once we get our assembly constraints together, we're fully constrained, we can once again do our wave geometry linker, and I'm going to link the blank as well as the master model. Again, once I have those linked up, I can just hide the master model and the blank away because now I have my linked bodies. And those are what I'm going to use once again inside the workpiece. When I define my part, I'll use the linked bodies instead. And the blank, I'm going to use the geometry that I created. For the MCS mill, now I can use the blank geometry again. I can just snap to points quickly, or I could use, easily use 3 planes and select an X, Y, and Z, and it'll snap to a plane quickly, or a corner quickly, or between 2 points. I can utilize the opposite corners to get the dead center of the raw stock for this part. And then from here you can go ahead and hide your blank away, and you can proceed throughout your tool creation, your operation creation, any manufacturing changes. But I can show you the master model concept of it flowing upstream versus downstream. So we'll start, maybe I'll move, remember this is the linked body, so I'll just move a face on this. So we can see we've moved a face here, but on the multi-tool master model, that face is not moved. However, if we were to, I'll do a pull face here. If I were to pull a face out, let me pick a different face. If I were to pull a face out, for example, we would see on the linked body, it's going to flow downstream into that linked body and alter our linked body as well. So that's where you'd want to leave those final revision changes to the design team on the master model, and we can still change our linked body for our manufacturing changes here. So let's go ahead and take this a step further. We're going to look at a gearbox that likely you would just have a casting for this. So how can we build a casting? And we'll even make this, we'll make this one associative to the master model. So again, we're going to go ahead and create a new file, a manufacturing file off of this gearbox using the part to reference as the gearbox. So here in our gearbox setup 1, our manufacturing environment, we're going to create a new component similar to how we built a new component for our blank. We're going to create a new component here as a model, and we'll do this as our, we'll just name this one a casting. We're not going to select an object. We're going to build it in context. But we're going to go ahead and save the file so that we have something to build inside of. Now I'm in a manufacturing environment, but I actually want to jump into the modeling application at this point to, we can see we've got a casting part file, but it's actually empty. So we're going to make it our work part and design in context. We'll use our wave geometry linker tool once again, and we're going to link the master model inside this casting part file. So now we have an associative linked copy of the master model inside of our casting file. In fact, if I open this in the window now, I actually see a linked body of that part. Now just so we can keep some things straight, what I'll do is I'll change the color of the linked part, and in fact I'll make it translucent as well, just so we can see the difference between the two. And now I'm going to treat this as, where's my excess stock on the casting versus on the real part, on the finished part. And we can do all that with the synchronous modeling tool. So for example, I'll start with deleting all of these holes, 1 inch or less holes. So I'll pick a hole, all the holes will be deleted. I'll delete some other faces as well. Probably this, maybe I'll just delete this counterboard or this partial counterboard hole. We'll do that one as well. And for the rest, I may just want to do an offset of some faces. And we'll just add stock where we think where the casting would be. I think on the bottom too, we'll do these as well. Offset may not work because I don't think that radius is tangent, so we'll just do a pull face on those instead. We'll pull those up at 100,000. So now we have excess stock. So as I save my part here, I can look inside of Gearbox Setup 1, and we have associative geometry for our blank inside the manufacturing environment. And we can even look as I change things on the gearbox itself on the master model. If I move a face in here, let's move a face over here as well. As I change these, then in the gearbox casting, you can see that those are automatically updating because they're linked, they're associative. They're an associative linked body back to the master model of gearbox. So now if this gets updated, our toolpaths, we can just automatically regenerate our toolpaths with this linked associative machining geometry. So then at this point, again, we could add our other components such as a vise and constrain. Make our assembly constraints at this point using our geometry that we created. I always like to start with that fixed constraint. And this one we don't have to bond together because it was created using that associative linked copy. So once again, pretty simple to constrain everything from here on out for these parts. There we go, we're all set up to machine this part. We just have to simply switch back over to manufacturing. And we can do our wave geometry linker. We want to link, because again, back to the setup one, back to the manufacturing part, manufacturing assembly part, we want to link that, we want to link the components, we want to link the blank, and we want to link the master model. Now we can hide the components away. Now we just have the linked bodies here inside the manufacturing file. And those are what we'll use as our part and our blank. Again, our MCS mill, we can use this as a point on our either our part or our blank. So we have all that defined. Now we would go into creating our tools, our operations, and so forth. Let's do one more scenario with a little bit more of a simplified block that we can make associative as well. So I'll start with a new file, manufacturing file, and again I'm going to go into my assemblies tab and create a new component inside this assembly, and we'll name this one Associative Blank. Again, we're going to leave it empty and we're going to create it in context. So we'll flip to modeling and we'll make it the work part, open up Associative Blank and make it the work part, and we're going to create an associative link between these two files, these two models. Now we can go right into Associative Blank if you'd like. You can just open that one in its own file, and we can create the blank out of this. Again, I like to recolor it right away just to keep them all straight. I even like to make them a little translucent. And now we can just simply delete some holes and delete some slots out of this. Delete some slot faces now. So now we just have a basic blank for that, and we'll do an offset on the sides so that we can add some stock on the outside of an 1/8 inch. The top to 50 thousandths and the bottom to a 1/4 inch or so. Now as I go back to the clamp block setup, we see we've got our blank created for us once again. So again, we could add a vise into this part. Move it into place and set our assembly constraints. We'll fix the vise. And we can touch a line for the part itself. Distance to the bottom. And one last one on the back jaw. Then as soon as we get the constraints finalized, once again, for our manufacturing file, we want to wave geometry link the new blank and the master model. Once we get the wave geometry linkers, we can hide away the component since we have the linked bodies. Now back in the manufacturing file, we can once again define our MCS mill position. Place that on a corner. And define your workpiece once again as your linked body of your master model. And your blank is your linked body of your blank. You can hide your blank away and continue with your programming from here. Thank you very much for watching this video. I hope it was helpful.